About 1/3 of food produced globally goes into waste. Unfortunately, these food waste end up in landfills, which produce greenhouse gases that contribute to 10% of global warming. And so we discovered that there was a way to convert these waste that goes into landfill into valuable products, such as the animal feed, at the same time getting frass fertilizer from it. My name is Daniel Moshi, and I'm studying electrical engineering at Ashesi University in the class of 2023.
My name is Mnashe Nyazenga, and I'm studying computer engineering in the class of 2023.
For our capstone, we worked on a black soldier fly incubator. It's an incubator that automatically monitor and control the life cycle of the black soldier fly. So the black soldier fly itself has 4 life cycles. That is the egg, the larva, the pupa, and the fly stage. And so the system is able to monitor and actuate all conditions necessary for the flies to grow until the final stage. The whole system comprises of mechanical structure, electrical, and then computer programming. And so the mechanical structure is basically dividing the whole system into different chambers such that it could be favorable for the egg, the larva, the pupa, and the fly, because each of the stages have their own set of conditions that allows them to grow very well. And so upon building the whole mechanical structure, we needed electronics to be able to control how each of the systems should keep track of whatever should be happening.
The programming aspect of the project involves programming the microcontroller, which is an ESP32 microcontroller that you feed in instructions, and the instructions are then stored, and then you can be able to control the temperature, lighting, humidity, and the moisture content of the food.
This is the black soldier fly incubator. It is called FlySol, meaning fly solution. In here we have LCD display that displays whatever is happening within the system for the user to view. We also have power switches for you to switch on whatever you need to switch on to control. We have LED indicators, red for grid and then green for solar. And so it indicates which power source the system is using. In here we have the first cabinet, that is the egg stage, where the flies come in here to lay eggs within the cavities of something called eggies, which is placed within it. When they lay the eggs, they keep here up to 5 days. And so after 5 days, the system opens for the eggs to fall into this chamber called the feeding chamber. Now the feeding chamber is where the user drops their organic waste substrate through this section, and it falls in here. So it is equipped with a moisture sensor that is able to sense the moisture content of the feed, and then it stirs to mix whatever moisture that is being dropped. It also sprinkles water to the moisture so that it becomes appropriate moisture level. There's a fan that is able to cool the temperature down when it is too high, and there's an infrared lamp that is able to warm the temperature up when it is too cold. We also have a red LED here that turns on for them to be able to feed very well. And we have a camera here that is able to monitor whatever is happening within it. When they are done feeding and growing, they have a characteristic called wandering. So they would like to move out of the feeding section, and they'll move through this section and fall in here. So at this stage, it's a 50-50 chance of them being fall to a first cubicle where it weighs and then report back to the user the weight of the harvest collected. And there's also another section where when some fall in there, they stay there, pupate, and become flies so that the cycle continues, because after 10 days they will die off. And so whatever is collected in the harvesting container would be weighed and reported back to the user.